Bonjour à tous et bienvenue dans le cadre du Meetup Azure Québec. Aujourd'hui, nous avons la chance d'avoir parmi nous un nouveau speaker, un Microsoft MVP sur les technologies AI. Et donc, plus spécifiquement, nous allons avoir une présentation en anglais qui sera sur le End-to-End Data and AI Platform, Designing in Azure. Et puis, on est vraiment super heureux de pouvoir accueillir Raha. Et puis c'est tout. Je vais te laisser te présenter. Yeah, thank you so much,
Thank
Raha,
you.
to be here with us tonight for this meetup presentation. And I will let you introduce yourself, and if you can just introduce yourself and start the talk. And for all the participants online, if you have any question, please do not hesitate to ask your question directly in the chat. I will try to reply or try to interrupt Rad. And at the end of the presentation, I think we will keep some minutes to do a chat between you and the speaker of tonight. And thank you so much. The floor is for you, Ra.
Thank you so much. Thank you, Max, for inviting me. Unfortunately, I will give the talk in English. As I said, my French is not that great yet. So, and thanks for inviting. End-to-End Data and AI Platform, designing in Azure. So the reason behind giving this talk is we usually attend a lot of talk regarding data and AI, mostly in AI, and they're sometimes sales focused or product focused or some kind of random POCs. But we rarely see any presentation or any opportunity where we get to see the end-to-end components, the components that you need for an enterprise level to have to build a solid data and AI foundation, data and AI platform, and within the Azure environment. So today's agenda, most of the things that I will cover today are enterprise data and AI strategy for anyone or from any organization. If you are thinking to invest in data and AI, what are the things you need to do and how we do the calculation based on where are you based on the enterprise strategical point of view. End-to-end data and AI platform, how the platform looks like, what are the things you need to do, data and AI lifecycle, data and AI key personas, all those new job roles that have recently evolved the last few years, ideal data and AI components, and Azure data and AI services, all the things that are off the from the shelf. You can just pick them and use them for your own purpose. So before I jump into the presentation, if I just give a small intro about myself, my name is Rath Yasir. Currently, I'm working at a data and AI platform architect at CAE. It's been quite a few years, 8 to 10 years, I believe. I'm working in this data and AI industry, in quite a few places. And my educational background, mostly computer science, AI, AI policy, technology, those things. As Max said, I'm a Microsoft MVP for 6 times. That's a lot of times, I know. And I also got Canada's top Dev 30 under 30. When I think about Azure, Microsoft, and those things, it feels like that was just a couple of years ago, I got my first MVP award and started my Microsoft and Azure journey. But it's been already quite a few years. But the good thing is we are getting all the components and tools that we need to evolve our career from an enterprise point of view within Azure ecosystem. That is the reason why I still stick with the situation, with this platform. So before I jump into the presentation of all the data and AI components, what you need and what you can have, so I would love to focus on some recent surveys or numbers. So a lot of people says that data and AI it's just big hype. It's just buzz. Not really. So if you look at the number, it is believed that by 2025, AI market will be $60 billion. In 2016, it was just 1.4 billion. And if you consider AI and data together, it's way bigger than that. So the number is actually just on the rise, and it's going to grow more and more and more. And how AI actually helps any business. AI can increase business productivity by 40%. So now you can ask like how are we measuring the number 40%? The thing, this 40% comes from all the new features that data and AI is offering, from understanding your customer, offering new business like features, offering new services, being ahead from your competitors. All of them together gives you that opportunity of increasing your business productivity by 40%. And not only we all know that like COVID has great impact in all the business sectors, but the interesting thing is like because of COVID, our data and AI industry got more investment because with the COVID, with the COVID situation, we realized that we need more automation, we need more like a data-driven decision-making approach or data-centric decision-making approach. We need more AI to have less contract with humans. We need to be more autonomous. So that is the reason that our AI industry got more investment than other industries. So those are like very high level numbers, and it's just like continuing, and it's just going to continue in future as well for both the growth of data and AI. So if you're like a business person or a technical person, if you're thinking, okay, you want to learn something new or want to introduce data and AI within your organization, there are some ways. Yes, you can randomly invest your money and incorporate data and AI within your organization, but you need to know how much value it's going to bring. So before you invest anything throughout your organization or start random POCs or random like data repositories or data lake, you need to have some kind of like data and AI platform strategy. So the data and AI strategy is actually combined of like three things. One is data. You need to have all the data sources, proper data lake, data ingestion, cold and hot storage like planning, data processing planning. Knowledge and skill. You need to have data science knowledge, analytical capability, dashboard and visualization, and artificial intelligence skill within your organization. And the third wheel is information context, which is the data and AI platform, which is combining both of them. Information management, information architecture and data flow, information security, and governance. So when you combine these three like components together, data, knowledge and skill, information and context. So data and information is giving you the understanding, knowledge and information is giving you the data culture with all the governance and data centric decision making, and data and knowledge is giving you ROI and business driven priority or opportunity. So in total, with this three approach, you actually set AI and data centric planning. So we cannot just expect to start a like AI team and without having proper data and information strategy to get benefit or like a revenue just from a single approach. You need to have, yes, the context or the scope could be smaller, but you need to have all of them. So if you are representing any organization and you think, okay, we have some data, now we want to see like how far are we from a data centric or AI driven organization to be fully autonomous or on that level. So just like those big organizations like Microsoft, Google, Facebook, LinkedIn. So this is a kind of like a pyramid scheme or like a metric that we can use. A lot of times we use that to identify where is your organization standing within the like data centric and AI driven organization scheme. So the first step of any kind of like data and AI strategic approach is collecting the data. You need to have proper planning or resources so that you can get all the data within your like from your organization or your partner organization or from different systems. So that is the first part. Second part is once you collect all the data, second thing is all data is not like just having the data doesn't prove anything. You need to know that what kind of information you can get from this data, like getting the data inside, getting the KPI. So you need to develop those kind of like identify the KPIs, identify the insight, and design different kind of like POCs based on the data that you have collected. when you design those POCs, yes, it is POC. It looks cool, but is it gonna bring any value? No, it's not. So while you're doing POCs and like doing testing your data, finding KPIs, doing those business validation, you need to set up data management, data governance, like process. And this on the number three step, which is the knowledge base, will help you to start to think about your revenue generation from data and AI. Collect data, make your data into information, and then set up all the best practices so that you can actually turn your POCs into revenue. When you're doing all those things steps in the knowledge section, you will make a lot of mistake. And in the fourth step, which is understanding, you will realize and understand all the mistakes you're making, and you will fix them. And then you will identify the proper return on investment of your investment in for data and AI, like a platform. And you will have that experience. You will reiterate, like based on the learning that you will have from your knowledge section. And from this understanding, when you're fixing yourself, updating yourself, having the perfect ROI of your investment, then you will get into the number five, or the last stage, which is insight. And this is the place where you will be able to apply learning and understanding from your data to become a data centric and AI driven organization. So it's not like you will start a like a small like data team or AI team and expect to make a revenue and become completely autonomous. Yes, you can always start from something small, but you need to like keep this pyramid approach in your mind, that collect the data, find out this data has the value or not, identify all the KPIs, convert data information into knowledge, so that with those management and governance, you are actually solid, and you don't have any like gap within your platform, so that in the next two phases you can actually use a data and AI and make revenue and become like a data centric and AI driven organization. So this is the ideal approach that we see in the data and AI industry. Now, the thing is, as we will talk about a lot of things today, so data and AI components, so what are they? So before I jump into like data and AI components or Azure, what Azure is offering, I have like divided a presentation in a bit like different approach. One is I will talk about data platform. What are the components you need to have within a ideal data platform? And then what are the key personas you need to have within your data platform, and then what Azure is offering. And I will do the same thing for AI as well. So I know there is like lots of information that I'm going to show. Just feel free to stop me and ask me any question if you have. And I like take it as a story, and also like try to think when you are like what you see, like if you see all those, like when you see all the diagrams, and try to relate with the actual situation that you are doing or using within the Azure ecosystem. So
I
that
think I'm sorry to interrupt you. I think we have a first question.
Sure.
Yeah, I think this question is from Tijani, and it's don't you have to do some processing on the data in order to identify if it's has a value or not?
Yes, I will show actually all those individual steps from a data science point of view, KPI point of view as well, and that will kind of like give the complete idea. So that the answer of the question will come through my presentation.
Perfect. Thank you so much.
Thank you. So the data platform requirements and components. So the first thing is, before we jump into like spend a lot of money in Azure and have like a big data lake, what is the life cycle of data ingestion and key personas? Who are the people who will use it? So the data ingestion life cycle and key personas, I divided into like this through this diagram. There are like 1, 2, 3, 4, 5, 6 common personas within the data ingestion lifecycle, and 6 different tasks. So first is business leadership. They will set the goal. Then the data architect for any organization, they will review the data source, and do the planning or design the architecture of the data ingestion. Once the architecture finalize the planning or the architecture, the data engineer is the one who will like do the actual ingestion, they design the pipeline for schedule-based processing or like ingestion or real time or anything else. So data engineer is involved here, and then the data modeler. A lot of times, what happen? We ingest the data, we keep it in our data lake or something like that, and the data needs to be exposed as a reporting or dashboarding like Power BI or BI based analytical system. So in that case, we have data modeler who is like working with the data to do some kind of like schema, star schema, or that kind of changes. So right after the ingestion, our data modeler are the one who does the data modeling and also who does the data reporting or visualization. And there are data visualization and reporting developer as well, so they are the one who are finding, looking at the data, generating those graphs, trying to find out different kind of like patterns or information so that the higher executive can look at the data or the report and identify those decisions. So this data visualization and reporting will be on last two like phase. And then the last one is data analyst and scientist. So once the data is ingested, it is residing. Sometimes data analysts or scientists just need the raw data, or sometimes they need the modeled or curated data. And their approach actually starts from here, and they actually go through their approach till the end. What is the value of this data? Whether this data has any KPI or not, or identifying any kind of like new pattern, or designing any kind of like data science or AI based model. So all those like individual tasks are happening in a sequential approach. And before you like ingest your data, there is no way you can like identify, because you need to ingest your data and then you need to like make your data secure, proper like following proper governing approach, and proper those GDPR and all those regulations. So that's the kind of like approach I see for data ingestion lifecycle and data key personas. Now the thing is data platform components. So within this approach, what are the things we see? The first thing is, in any kind of data platform, we need to ingest the data. After the ingestion, we need to store the data. Then we need to transform the data, as we got a question like how do we transform it, or like find KPIs and those things. Once we transform the data in different zones or different places, we need to do some kind of reporting or visualization. After the reporting and visualization, we do data consumption to other systems or other tools or different kind of services. And while we are doing all those like number 1 to 4, we also need to do data governance and data management. Now the question could be, why do we need data governance or data management? Because we know all the like data security stuff, data privacy stuff. If you ingest some data and it is some kind of like credit card information or PII or personal health information, then like you need to follow those regulations set by different regional governments, or like from like set in different regions of the world. So you need to have it. And also, not everyone should have access to all the data. So your like there is a thing called data steward. So they are the one who are like setting up based on the data owners, owners plan and access management. They set up who should have the access to what schema. And even if I don't I should not have the access to the data, but as I'm doing some kind of like data processing or development, I will see the metadata, but I should not see those values. So the data should be masked before if I like dig into that one or do some kind of query. Yes, I will see this table, but all the rows of that table of those individual personal information should be masked or that kind of like hidden. So that's why we need like data governance and management. And also we need data exploration for sandbox or marketplace or data quality. Because yes, you can have all the data in the world, you can ingest them, but what is the value of the data? You need if you don't do any kind of like design any kind of data analysis, or do any kind of like data modeling, or any kind of decision making. So you can have like a data exploration sandbox where it's secure, like no one is able to like download the data, but it could be used for just exploration purpose. Or you can have marketplace where all the data sources are exposed as a full glimpse, so that you can just go and see as a data analyst or business decision maker that what kind of data you have, what kind of KPIs you can find, so that you get the full idea. And the data quality, you need to also, like when you're doing the data ingestion, you need to identify whether this data is garbage data or good data. So you need to do those quality validation as well. So these are the high level components for any kind of data platform: data ingestion, data storing, transformation, reporting, and also all the other like stuff. So now if we look the all those 7 steps in a complete diagram, then what we see. So that's how we see it. So data platform components, as I said, there is data ingestion side, there is data store side, there is data process side, there is data serve and enrich cycle, and the last one is data discover govern. So for the data ingestion, when you design the data platform, you are ingesting a lot of data from different systems, from different databases. The database could be on-prem or cloud. The system could be anything, mobile, web, or any kind of existing software application, or it could be like a public data sources, your stock data from New York Stock Exchange or Toronto Stock Exchange. So all those data ingestion needs to happen like in 3 ways. Data migration, you can migrate it. You can have like real-time data ingestion, or even trigger and pipeline based data ingestion. Once you set up your data ingestion process, you need to store them. So when you store the data, you will notice you have 2 types of data: structured data, unstructured data. When if it is like a normal tabular data, they're structured. If it is like mostly flat file, image files, audio, video, or that kind of like Parquet files, they're unstructured data. So you need to keep those in your mind when you're designing the data store. You need to have 2 types of like mechanism for archiving, because yes, data, you can store all the data, but it's also expensive to keep that much data in the hot data storage. So you need to have like a cold storage too, because if you're not using all the data all the time, what's the point of like keeping all of them in an expensive a storage place? So keep it in the hot one, and you need to have a like automated archiving process, so that every 6 months, 1 year, or 2 year, the data that you have in the hot will be automatically moved to the cold storage, so that the archiving is properly done. And also you need to have like proper backup and restore strategy, so that you don't lose any data. When you design the data lake zone, you need to have different kind of like storage zone as well. So when you ingest the data you keep it in like a raw zone. Then you can do some kind of like processing of the data, like formatting or like adding. They could be in the another zone, like bronze or gold or transient or anything, like the way you name it by yourself. And then after doing all the cleaning, processing, curation, then you need to have like data in a like a curated zone. So you need to maintain those zones, and you need to separate them based on your need and organizational rule as well. Data security, your data storage needs to be very secure and untouchable. No one can should not touch it unless they get the data in a masked approach, or they're allowed to touch it. It's because there could be personal information, and it is a very important thing. And data KPI. So you need to have like some kind of approach for metadata management. So what kind of data you are ingesting, what is the value of those data, what kind of KPI you are getting. So like managing all those things. So just in the store side, you need to keep all those things in your mind. Then the data process. So as you are having all the data, doing all the like schema and all the generation, but the purpose is like having some kind of reporting or visualization. So that is falling under the reporting process or data process. So you can have like Power BI, Domo, or any other kind of like Tableau based data reporting tool that will be connected with your data sources, whether it's a data warehouse or any other like data source that you have, and show those like a visualization for your different like executive like teams. Then the data transformation, as I said, your data needs to have different in different zones based on raw, transient, and curation. So those individual zones, and the data transformation needs to happen through some kind of like Spark pool, or some kind of like Databricks based, Apache Spark based like scripts or coding or that kind of things. So you need to like keep that one in your mind as well. And while you're doing that, your data analyst will work here, like from the data of here. So they need to do the data wrangling. They need to take the data, the raw data. They need to do sometime connect all the data tables, create one master table, do the data cleaning, data processing, different kind of like regex based function or data manipulation. All those things needs to happen as well. And the data, you need to like bridge the gap, like remove the gap between the data and computation. If you need to like copy the data into 10 different places, that is going to be very expensive. So the way you need to design it, where the computation will come and reside near the data, so that you can do like run different kind of like scripts for data transformation or wrangling or that kind of things. And all those like data transformation steps that you're following, you need to like store them as a recipe as well. Because if you like do some data processing for some kind of like modeling from up, and you go through 10 different steps, and you need the same data but in number 5 steps for some kind of like AI modeling, so you cannot just like run all those like steps again and again. You need to store those recipes so that you can reproduce all the like reports, reproduce all the data processing or data transformation steps. And the last part is data serve and enrich, which is data consumption, data share, that kind. So data consumption will happen to other systems. So you will connect your data with other web-based system, mobile system, or that kind of systems. Or data share is also like similar to that. But what is the purpose of having all the data? The main purpose of having all the data is having machine learning use cases, proper data democratization, exposing your data throughout your organization through data marketplace, having more data exploration to find out the value of the data, meaning of the data through different kind of like data sandboxing approach, having different kind of like data reporting and BI based features throughout your organization, and making the entire approach process automated through data ops and ML ops approach. And underneath, we have the cloud data platform, data governance, and everything. So now the thing is, this is just like a high-level diagram, how a data platform should look like. Now the question is, what is Azure offering to us? So the next slide
Maybe.
is, sorry, yeah,
Yeah,
Maxim.
I will try to interrupt you because
Yep.
we have another question.
Yeah.
And the question is, how do company typically handle garbage data? How the company manage the garbage data from your experience? Maybe if you can share a
So I have
little
seen
about
like
that.
two different things actually. I have seen companies ingesting all the data, terabytes of data first, and then then they were like scratching their head. Okay, what is the value of this data we just ingested? So in that case, they see sometime, okay, this has good value, or this doesn't have any value. Sometime like for few years, few quarters, they keep it, and then they realize, okay, there is no value of that one. That's the one approach. And the second one is, before you ingest any data, try to find out why you are ingesting it. What is the business process, like a purpose? What is the return on investment of this data? What is the KPI of the data? So whenever you are looking at doing the data ingestion, looking at the data from different sources, you will see this data is representing your sales or stock prices or your internal finance or HR information. Based on those, ingest them and do those data processing to find out all those like modeling and KPIs. If you realize that this data doesn't have the KPI that you need, it's better not to spend money on that.
Okay, perfect. Thank you so much for this answer.
Thank you. And so this is the end-to-end like Azure infrastructure, as I said. So we will also take a look what are the components that Azure is offering. So if you can have like different kind of like sources. Suppose here, this is the streaming sources. This is the unstructured data, image, video, audio, as I said. This is the semi-structured data, CSV, logs, JSON, and these are the structured data, relational database. So your you can have source from anywhere. So when you're doing the ingestion in almost streaming or real time, you can use either Azure IoT Hub or Azure Event Hub, or for like event-driven approach. And then you're using Azure Stream Analytics for Power BI based real-time reporting, or different kind of like cognitive service or Azure machine learning based approach for modeling. And then you can also like expose it for analytics or business user or other applications. If you are having some kind of like unstructured or semi-structured or structured data, you can use Azure Data Factory for to create that kind of like pipelining or trigger, which is also like a when you look at Azure Synapse Analytics, it's a part of, you get all the pipelines that you get from the ADF as well. So you can use Azure Synapse Analytics to create pipelines from different sources, and just ingest all the data in your Azure data lake, which is also offered by Azure. And from the Azure data lake, you can also do different kind of like warehousing capabilities, do different kind of like data transformation that I said using Spark Pool from Azure Synapse Analytics. You can also do different kind of like serverless SQL pool, so that it's actually way cheaper than similar tools in the market, from yeah, from different organization. And also you can expose those like data lake, data warehouse, all those like data transformation through Power BI based reporting, or if it is a like just consumable data, you can have a like data driven application to expose it through Cosmos DB, or even you have like a shareable data as your data share for your application analytics and shared data set. And all those individual steps that you see are properly governed and managed. I also mentioned like the data governance and data access management. You can use Azure Purview for underneath, so that what kind of data you have, the data, who has access to this data. Like if I don't have access to this data, but you want to expose the data to me, the data will be properly masked, and like properly governance will be managed. You can also see in the Azure Purview, like future say, like version, I saw it like recently, that how the data is like moving is happening from one region to another region. All those things are already there, and as it is like a completely native approach, so you get a lot of like extra benefits from Azure Purview. And on top of that, you are getting Azure AD, Key Vault for security, like secure key storage, cost management, Azure monitoring, security center, and everything else. So this is what Azure is offering. But also, you can also tell like, okay, there are other tools that also like sits within this approach, where we can have different kind of like machine learning approach, machine learning tools, or we can have data breaks, or we can have something else. Yes, we can have those things too, but at the same time, from an Azure point of view, all the components within the that you need for an enterprise data platform, you are getting it from them right away. And also, like from the cost point of view, most of them are serverless, so it's also like you can easily monitor and manage the cost as well. And you don't need to like move the data. You can just like have the data in one place and connect all the machine learning approaches, cognitive service, and the Power BI and all those like reporting throughout, like while supporting this ecosystem. So that is the end-to-end data platform, the way like we see it from the Azure point of view. Now the second question is like, what about the AI platform looks like? Is it just this one? No. When we talk about like AI, it's a bit more than that. So now we will look at the AI platform requirements and components. So when I'm like showing about the AI platform, I will talk a bit more actually. Uh, it's just like 35 minutes. We have way more time. So perfect. So when we talk about AI, artificial intelligence, so we thought like, okay, is it just machine learning, AI, deep learning, data science, everything is the same thing? Yes and no, because AI, we call it like like the full ecosystem. We call it like artificial intelligence, because it is nothing fancy. It's just like a computer program which tries to replicate the way human takes decision. We all human, like we take decision based on a data driven approach. If I have experienced it, and then I try to like replicate based on my experience, the data that I have in my head, to take, okay, this is my friend, this is not, this is mouse, this is, to do all those like object recognition, which is like called cognitive senses. So AI does the same thing. So the entire bucket or the entire umbrella, we call it artificial intelligence. Machine learning is just a subset of artificial intelligence, and deep learning is another subset of machine learning. So that's how the hierarchy works. And if you look at data science, it is actually residing in all three of the buckets. So AI, machine learning, data science. Without doing data processing, the science of the data, finding the value, and finding the meaning from the data, all the machine learning, deep learning AI has no value actually. So that's how the AI looks like, AI ecosystem. And there is another thing I just want to mention on the deep learning. When we when the AI model decide all the features by itself based on the data, we call it like, it's kind of like, it's an example of the deep learning. When humans select all the features, those are kind of like handcrafted features, and tell them if these are the symptoms exist in the data, this is the decision. So those are machine learning approach, and the data science is mostly finding patterns and different kind of like data driven information. So now again, from the just like data lifecycle, like if you look at the AI and machine learning lifecycle and key personas, these are the key personas we notice. So there are six key persons. One is business leader, again, data engineer, data scientist, machine learning engineer, app developer, and IT operation. So, and also there are like those six steps. First one is business leadership or BA or like executives. They need to identify this is the goal we want to achieve. Based on the goal, the data engineer is ingesting the data. They are gathering the data. They're preparing the data. Once they gather the data, once they prepare the data scientists are the one who develop the ML model, who take the data, play with the data, do different kind of experimentation, do different kind of visualization, try to find out pattern matching. Okay, this data has something. This is the model we can design. Then they will design the model, and then machine learning engineer works from here. So they take the model that data scientists have designed. So usually data scientist does all the modeling part. They give one scoring file, the trained model, and a YAML file to the machine learning engineer. And machine learning engineer is the one who creates those ML ops automated pipeline, so that you take all the three files, model, YAML file, scoring file, create, containerize them, and then host it as a RESTful API, so that other web application, mobile application can communicate with that. So machine learning engineer creating, deploying the model, and then connecting the model with the app or web application or mobile application with the help of app developer. And then they're the one who are also monitoring the model, how many requests that the model has processed or predicted today, if there is any data drift or not. Data scientists will also work at the end to find out whether this model has any value after 6 months or not, because model becomes obsolete after a while. I will discuss why, but this is the end-to-end approach. Business leader, data engineer, data scientist, machine learning engineer, then the app developer. They connect the model with the different apps to APIs or any other service, and then IT operation, which supports the end-to-end approach of cloud infrastructure and everything security. So that is the AI and machine learning life cycle or key personas looks like today. And you cannot just avoid one and try to have all the others. No, that will be a problem within the ecosystem. Now, I was also showing, talking about data ops and ML ops. So maybe you guys, some of you have a question. Okay, what is data ops, ML ops? We have heard about DevOps. So in our traditional application development lifecycle, it is DevOps. But whenever it's we talk about data and AI lifecycle, it is DataOps and MLOps. So what does a DevOps does? They create CI/CD implementation, ensure all the collaboration between teams. They try to set up those deployment and stable our platform. They host different environments, works in application platform on an infrastructure level, so that all the like application or code that we are writing are going into production after proper test. There is no issues with load testing, load handling, and those things. Those things and the infrastructure as well are done by the DevOps. But the same thing when we do it with data and machine learning or AI, we call it data and data ops and ML ops. So automating that approach, having the proper automation of model training, model monitoring, like we call it like that CI/CD, which is actually CT CI/CD. So that is actually data ops and ML ops. So you can also ask, what is CT CI/CD? So CT is continuous training, CI is continuous integration, CD is continuous development. So it's not like you will train the model once and done. No, you need to continuously train your model. You need to put them in production. You need to test them, and then you need to put them in production and continue that life cycle again and again. And while you're doing that one, you need to your data ops will ensure that the data like the data quality is properly managed, ensured. The times the life cycle to bring the data is less. MLOps will ensure that the model deployment is done properly. The model is monitored, because every time you're putting a model in production, just take an example of insurance model. Based on that model, you are asking for money. It's like a $10 insurance premium or $15 insurance premium. As you're making money using those AI model, you need to monitor them. And also you need to have reproducibility. It's not just you will design one model, then no. You need to have proper traces. You need to explain your model to different governing bodies that your model is doing what it is supposed to do. And your model needs to scale to serve a lot of make a lot of requests or responses or a lot of prediction. So all those things are actually done by data ops and ML ops people. Now the thing is, when we talk about data and AI or AI application, we sometimes get confused because there are like image processing, cool facial recognition. I also gave the insurance example. So with how many example can we have, or what is how do we define or set the proper structure of AI applications? So AI applications are divided into three different categories. One is category one, text and number, like classification, uh, regression, time series, recommendation. So the after doing the any kind of shopping in your Amazon application, Amazon shopping cart. So if you get a new recommendation of buying something new, that kind of recommendation engine is using category one data. Predicting the insurance premium, $10, $15, those numbers, that is regression example. Whether your tomorrow it will rain or not, yes or no, that kind of classification example is a classification. What will be the predicted revenue of next quarter, that kind of time series forecast. Or what will be the predicted temperature of tomorrow, that is time series forecast, that is category one data. Then some of us have used Google or Siri or Cortana. Like we can tell them, hey, what is the temperature in Montreal tomorrow? We get, oh, tomorrow's temperature is something like that. So that kind of conversational information are category two data. So from those conversations, we try to find out key phases. We try to find out what is the sentiment. Based on those key phases, we take the decision. Tomorrow's temperature, Montreal, they do the query within the database and tell you tomorrow's temperature in Montreal is 20 degrees Celsius or something like that. And the third one is image and video. So whenever we see any kind of facial recognition or image detection or image recommendation based on the existing shopping experience or Tesla autopilot car, those are the example of category three data, image, video, or multi-dimensional AI application. So category one, category two, category three. Any kind of AI application will fall under one of these categories. Now the thing is how the AI application development works. I wanted to just okay, this is there. So if I just give an example, just sorry, yeah. This one. So when we do modeling, I will show something just to describe this steps. So this looks a bit scary, this entire architecture, like a diagram. Oh, what is happening? So many things. So suppose we have the data today. This is the data, initial data set. The first thing we do, sometimes the data scientist, if I just like talk about modeling steps in 5 minutes, we do different kind of like dimensionality reduction, PCA, LDA, that kind of steps to like do some kind of like data analysis and to make the dimension smaller if the dimension is too big. If not, then it's fine. We don't need that. The first step is data pre-processing, which is cleaning the data curation, removing any kind of redundancy. Once we do that one, before doing any kind of modeling, this is the first part. And also identifying the KPI as well. We do it in this side. Once we do that one, then we have the process data. The process data will look like something like this. It's nice, clean. We know all the like features x1, x2, x3, x4, and also we know the target, A, B, C, or whatever. From the process data, we split the data in two different parts: training data, testing data. Sometime in three parts: 70%, 15%, 15%. The third part is like validation, but here I'm not showing it. I'm not showing it. From this training data, based on the data we have, we do like we take the decision, what am I doing? Suppose if it is a like insurance premium that I was like discussing, so what I want to predict, I want to predict the insurance premium of mine next 1 year or next 6 months, or a new user. So in that case, I will have to take the decision that it is a regression based model. We need to take the decision of AI modeling, and we need to take the decision what kind of algorithm we will use. There's so many algorithms in the market. So whether it's SVM, XGBoost, KNN, or whatever, based on the type of modeling, we will select the best algorithm. Each algorithm have also their own hyperparameter. So we need to do sometime we need to do that kind of like grid search of all the hyperparameter to find out the best combination of parameter for this specific model training. Once we find out, then we get our, after doing some kind of cross validation and everything, we get our final model. So this is our model, trained model. Then we will take that 20% of the data that we separated at the beginning to do the testing. From that testing, we will get to know this, like do the evaluation, whether it's a good model or a bad model, whether this model is useful or not, whether it is giving garbage or not, whether it's possible or not. And based on when we are doing the regression or classification or any kind of like modeling, there's some kind of like a bunch of like matrices we also can use to identify how good or bad this model is. So that's how the like data science or data modeling part works. Data, process them, do the like split, select the type of the model, select the algorithm, hyperparameter optimization, find out the model, use the testing data, do the evaluation, and then based on the metrics, and boom, you have the model. You have done some data science stuff. Now, as you have done the data science stuff, now what? So it is kind of like end-to-end. This one was end-to-end modeling approach. Now we will look end-to-end machine learning approach. So the same approach, you have the model, you go through all the data processing, data transformation, data validation, data featureization part. So 70% accuracy of your model depending on how good of a featureization or data that you have done on your data. Then the same approach, you do the algorithm selection or the type of algorithm, regression or classification. Then it's XGBoost or something else. You do the training, hyperparameter optimization, testing, validation, and then you deploy it. How do you deploy it? After doing the deployment, all the algorithm, all the libraries that you have used, you will create a YAML file to replicate the same environment. You will also have the trained PKL file or NPZ model file. You will also have a Python script as a scoring file. So what will happen, you will take those three files, create a Docker container of that same environment, put the model or like the scoring file with the model on that container, and wrap it on an API and expose it, that RESTful API, so that any mobile or web application will send a JSON request to that scoring file. It will take the JSON request, do some initial data processing, send the consumable JSON to the model, The model will send the response, $20, $25, $30 as a regression value, and then you will return it as a final response of your model. So that's how the model deployment works. You can also do batch processing, and you also need to just putting the model in deployment doesn't end everything. You also need to check whether your model is doing good job or bad job, whether your model is generating garbage or real value. All those things you need to monitor the model. Now your question could be, okay, I have done all those things. I have used the real data. Why would I do the model monitoring? There's so many kind of model monitoring. One is resource monitoring, how many requests you are getting, so that you can replicate the same pod into a multiple a cluster or single cluster, lots of replicas, so that it can process, handle that many resources or load. Also, suppose if you design a model, insurance premium prediction based on last few years data. Right now in COVID time, people are not driving that much. So if you use the same model, then it will be unfair for all those users. So you need to based on different situation, new data, you need to continue your training process, continue your model monitoring process, so that your model is always up to date and it's always generating good value. So now the question is, as we have talked about data science and AI steps, what are the components in an end-to-end AI platform? So there are five key components that you need to have. One is pre-trained model, because if you are if you have a use case of a small application, like nothing fancy, just detecting a face or expression analysis, collecting all the data, designing all the pipeline, doing all those things, that's a lot of work as well, even like data collection. So the ideal AI platform should offer some kind of AI option for pre-trained model, where the model is already trained, it is already hosted. You can just put it, just do the API call and use it. Then the second one is the ideal AI platform should have a machine learning platform, where your data scientists can do their modeling using Jupyter Notebook, or you can use automated machine learning if your data scientist is not that experienced, or do that kind of hyperparameter optimization, grid search on an automated fashion. Your machine learning approach should have a designer option, where you will just upload the data, drag and drop all those components that I have showed, and boom, you will have a very basic model. Your data science platform should give you like the on the shelf out off the shelf virtual machine, where all the libraries, CUDA or TensorFlow and every frameworks are already installed. And also, it's really expensive to have buy GPUs, and just for training purpose, your AI platform should give you that kind of computational components as well. So these are the top features for machine learning platform. Other than that, all the things I say, training and inferencing, compute cluster, your both container and Kubernetes cluster, that kind of benefits you need to have. Data annotation tool and ML ops, continuous training, model testing, model monitoring, drifting, deployment, that dashboard, all those things. But the good thing is, all those features that you have seen here, uh, Azure Machine Learning is actually supporting all of them. So it is offering you cognitive service, pre-built AI that has all the computer vision, speech recognition, search, knowledge base, that kind of pre-built common use cases already there. You can just use it. There is bot framework for any kind of conversational AI. There is custom AI for image processing based model training. There is AI tools like Azure Machine Learning Studio that gives you automated machine learning. It also gives you the Jupyter Notebook based Azure ML Workbench or support, so that you will write your own code but use all the computation from Azure as a virtual machine and other things. And also, for the data, you have the data lake, SQL Server, Cosmos DB as a unstructured or that kind of document DB, and AI compute, some kind of DSVM, batch AI processing. If you scale your AI application, AI model, you can use Kubernetes cluster, which is also properly managed. If you just want to do some testing, you can use container instance, and also for different kind of IoT application. So all those things are actually support and offered by Azure AI. So you don't need to do anything extra. So as we have less time, I will just like talk about this one. So once you do, this is the first step. Once you do your like modeling, you do your data sanity test, unit test of your model, and then you also do your create your machine learning workspace, compute, like it's a GPU based model or CPU based model, and everything is done. You will publish your machine learning like pipeline. So based on the code that you write in Jupyter or any other place, or just like you can also use Designer or other like Azure ML option. You will like push your publish your machine learning pipeline to train the model. You will train the model. You can evaluate the model. Once you're satisfied with your model, you can register your model in an Azure container registry. From the container registry, it's also managed by Azure Machine Learning Model Management. You can create a model package. You can deploy the model in an ACI container. It's a single instance so that you can test the model as a web service with your existing application. Or if you're convinced that this is the model I want to use, you can easily push it to an AKS deployment as a Kubernetes service, where you can have like multiple replicas of the same pod, same model, and expose all the replicas model with all the load balancing and proper facilities, which are also like managed by Azure through Azure Kubernetes service. And then you can have Azure App Insight, which will give you how many requests you're getting, how many responses you're making, prediction you're making. You can have log analytics to do all the logging. So from the model training to model testing to model deployment in Azure Container Instance or Azure Kubernetes Service, all those individual steps are actually offered in Azure Machine Learning Approach. And the last one is the same thing in a better approach. So when you do your model development or training, the way I usually do it sometime. So I do data ingestion in data lake, or and from the data lake, I use data factory, data bricks for different kind of like data transformation and processing. I like sometimes I also like use Databricks for batch machine learning processing. If it's like if I don't need to do those prediction in real time, I want to do it in kind of like batch and update them in based on the quarter, and then use the same data connected with the cognitive service or Azure machine learning, do the training modeling. Once I'm convinced, register the model and expose uh, the model as a container in a dev environment, or Kubernetes service for QA and prod environment, and just expose the endpoint, which is an API, through for a mobile app or web or other options. The data is I usually the production data, all those like requests and response I make, I keep it in the Cosmos DB. That is like a very handy like option to store the data. And for different kind of like analytics, what to monitor the performance, how many models we have in the cloud, and all those things. Sometimes I just use Power BI or automation or that kind of things. So it kind of like gives us the full like end-to-end approach for both the data and AI. So that's it from my side. I have talked about all the data components, all the AI components, what are the necessary tools that you need to have, what Azure is offering, and how can you use them, and all those metrics that you can use to identify where are you to become a data-centric and AI-powered organization. So that's it from my side. That's a lot of content to show in 1 hour. It's exactly 7 p.m. Thank you for attending the call presentation. And if you have any question, feel free to ask me. If you want to contact me, just or add me or connect with me through LinkedIn. Thank you.
Yeah, thank you so much for this amazing presentation. And yeah, thank you so much for that. And the content of this presentation will be available on the YouTube page of the Azure Quebec community. And if you want to just replay the session, you can do that by yourself. And yeah, the video will be available in few hours. And yeah, thank you so much for this presentation, and see you soon.
Thank you. Hopefully it was useful. Thank you.